Okay, Assalamualaikum and greetings to all. So, I'm Dr. Musawwa. So today I would like to continue on chapter 2, which is on convolution, because we already stopped using to find the zero state response and zero input response using um, the classical method, and also we already learned on how to find the impulse response. Okay, so let's start. Okay, convolution. Many naturally occurring phenomena can be modeled as a convolution process. It is defined as yk equals to xk convolution with hk equals to hk convolution with xk. Actually, there are a few techniques to solve for convolution sum, which is by using graphical method. Okay, we will learn that in the next class. By using analytical method, which is we will learn this in this topic, by using convolution table, and also by using Z transform. So using Z transform will be covered in chapter 3. So there are three properties of convolution, which are commutative, associative, and distributive. So commutative is xk convolution with hk equals to hk convolution with xk. Associative is xk convolution with h1k and convolution with h2k equals to xk convolution with h1k convolution with h2k and xk h1k plus h2k equals to xk convolution with h1k plus xk convolution with h2k. So we can find the zero state response by using impulse response and convolution sum. So in order to find the zero state response, we need to use the closed loop expression for some commonly encountered series. Okay. So these are the table, okay, that you need to refer to when you need to solve for the zero state response using the convolution sum. Okay. So we got that. Okay, how to determine the zero state response using the impulse response and convolution sums. Okay, using impulse response to solve for hk. So first of all, you have to replace xk with delta k, delta k here, and yk equals to hk. And then solve for the roots of the equation, and then use the initial conditions to determine the constant values. And next, okay, to determine the YZS using impulse response and convolution sum, so use convolution for between xk and hk to solve for YZSK, right? So first of all, use the found impulse response hk and the given input xk, and then find the convolution between the hk and xk, and then use the closed loop expression table to determine the solution of the zero state response. Okay, let's look at one example on how to determine the zero state response using impulse response and convolution sums. So example 1, this is actually from the notes, the PDF notes. So the difference equation of a linear time invariant system is given by yk minus 5 over 6 yk minus 1 plus 1 over 6 yk minus 2 equals to xk. So if the input xk is 3k uk and y minus 1 equals to 1 and y minus 2 equals to 1, so you need to determine what is the zero state response using impulse response and convolution sum. So the question already stated that you need to find the zero state response using the convolution sum. So how to do that? Okay. Okay, from example 2.5, we have hk, which is 3 half k minus 2, 1 over 3k. Okay, please refer back to example 2.5. We already did this before. Okay, and then from the original equation, yzsk equals to xk convolution with hk is y equals to from minus infinity to infinity, xj hk minus j equals to j equals from the summation from j equals to minus infinity to infinity, x k minus j hj. Therefore, you have to select yzsk equals to from j 0 until k, x k minus k hj. Okay, so this is the input. Okay, this is your impulse response, hk, 3 half k minus 2, 1 over 3k. And this is the input, x, k minus j, 3k minus j. Okay, since k minus j, so this is 3k minus j. And hg, which is the impulse response, we replace k with j. hj equals to 3 half j minus 2, 1 over 3j. Okay, to put into this equation. Okay, let me arrange my this. Okay, then yzs equals to, you substitute the input and the impulse response into this equation. So from j0 to k, 3k minus j, which is the input, times with 3, 1 over 2j minus 2, 1 over 3j. So this is the impulse response. Okay, and then you expand the equation from j equals to 0 to k, 3k 3 minus j. Okay, and 3, 1 over 2j minus 2, 1 over 3j. Okay, and then put the 3k outside of the summation, and 3 minus j, and then this is the impulse response. 3 minus j is 1 over 3j. Okay, j from summation from j0 to k, and 3, 1 over 2j minus 2, 1 over 3j, or 3k from j0 to k, 3 minus j, 3, 2 minus j minus 2, 3 minus j. Okay, so if you solve the equation, you will get this final equation, which is 3k, the summation from j0 to k, 3, 1 over 6j minus 2, 1 over 9j. Alright, and then we separate for both of this. Okay, when you separated it, you get 3k, and then put the 3 outside from j0 to k, 1 over 6j minus 2, the summation j0 to k, 1 over 9j. Okay, the two parameter here that I highlighted here, you need to refer to the closed form expression table. Alright. Okay, from the closed form expression table, alright, you have to refer to this expression. Why? Because you know that 136j, from j0 to k, 1 over 6j. So which one is similar from this 6 closed form expression? Alright, so this is the similar one from n0 to k. So we just put j0 to k, and you substitute with j. So aj. So here, for this case, a is 1 over 6. Alright, so 1 over 6, k plus 1 minus 1 over 1 over 6 minus 1. Alright, same goes to the next equation, which is 1 over 9j. So for this case, 1 over 9 is the a. Alright, so just replace it with 1 over 9k plus 1 minus 1 over 1 over 9 minus 1. Okay, these two, you need to replace it to the original equation. Substitute back into the equation. So first of all, you have to solve this first. So 1 over 6k plus 1 minus 1 over 1 over 6 minus 1. Finally, when you calculate everything, you will get minus 1 over 5, 1 over 6k plus 6 over 5. And then 1 over 9j equals to 1 over 9k plus 1 minus 1 over 1 over 9 minus 1. When you solve it everything, you will get minus 1 over 8, 1 over 9k plus 9 over 8. Alright? And then substitute both back into the equation. Right? So yz as k equals to 3k, and then there's 3. Okay, this is from this, and minus 2, this is from this. Alright? So next, you have to solve everything. When you substitute everything, so you just expand the equation. And finally, you will get minus 3 over 5 half k plus 1 over 4, 1 over 3k plus 27 over 23k uk, as in example 2.4. You can refer back to example 2.4 and you will find that the answer is similar to the example in 2.4. Alright, so this is how to solve the zero state response using impulse response and convolution sum, and you need to refer to the closed table. So first of all, you have to know what is the input of the system, and then you need to find the impulse response, then you can find the convolution sum. Okay, alright, so I will give you the exercise later on. Okay, with that, thank you.